So guys, we're gonna be doing sine A plus B is equal to sine A cos B plus cos A sine B. Okay, let's not forget that. That is our compound angle expression. Then the difference as well in our compound angle expression is sine A cos B minus cos A sine of B. So the addition, the sum of the compound angle of sine, obviously if there's a plus there, there's a plus there as well. Sine A cos B, cos A sine B. If there's a subtraction, sine A cos B minus cos A sine B. That's the compound angle, and that's a compound angle that we need to know. Okay, and it's quite straightforward, to the point, no problem. So for instance, if I look at an example very quickly where I'm given sine of x minus 25 degrees and I'm supposed to expand the following, then using the expression of the compound, sine x minus 25 degrees is simply sine x cos 25 minus cos x sine 25. Okay, so if I'm told to expand this is how I would go about expanding sine x minus 25, and I'm basically using the same template. You would say this is the sine A plus B template. Okay, so instead of A, I have x. Instead of B, which is B following, I have 25 degrees. But generally, we have that same template, okay, for that expansion. Okay, so let's look, that's one example. Let's just look at another one. Let's say we have cos of 30 degrees. Sine of 30 degrees plus 5x. And we are told to expand again. Then of course that will be sine 30 cos 5x plus cos 30 sine of 5x. No, this is not a pre-record. This is basically a live session that I'm doing. And no, I did go to sleep. I woke up very early. Okay, sine 30 cos 5x. Okay, can you see that A is sine 30, that B is 5x? Cos 30 sine 5x. So guys, what's beautiful is that all of this will be available. This compound expression will be available on your formula sheet. All then you would need to do is just sort of like look at the template. Okay, you know, sine cos, cos sine cos, cos sine, AB, 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 AB. All right, this is A, this is B. All right, and then the sign of, when it's the compound angle of sine, the sign in between does not change. So if it's positive here, it's positive there. If it's negative there, it's negative there. That's how we do it, grade 12s. Okay. And then of course, because here we have the special angle, and you are told to expand, then of course we are going to figure out what sine 30 is, because at this point in our grade 12 chain, we already know that, oh, sine 30 is a special angle. So then we are going to say a half cos 5x plus, and then we go and press cos 30. So that's cos of 30 degrees. We're going to go and press cos of 30 degrees. To expand that, we know that's the root 3 over 2 sine 5x. Okay. You see? Because we know special angles, and we learned special angles in the previous grade, which is why we are quickly able to pick up, oh, okay, this is half, this is root 3 over 2. Masala mamecha. Do I do maths N3? I do maths high school, but obviously your maths N3, you'll actually find that it's made up of much of what is the high school maths. So I think if you can give me a program of what you guys do, then I could do sessions for maths N3 students, and then we could take it from there. Maybe live sessions for maths N3 students is in the cards, All right. Then let's look at another compound angle. Cos A plus B. What about the compound angle for cos? Cos A plus B is simply going to be cos A cos B. And then this plus sign, it changes. Okay. So we say the C for cos stands for change. Alright. That's why this sign here changes from positive to what? To negative. But then what you can do basically is, you have the formula sheet. You don't have to memorize this, but when it's in memory, it's nice. The S for sign, this is the way I remember, means the same. So that means the plus will remain positive. But then look, it's sine A cos B, cos A sine B. But for cos, the C for cos means change, meaning the sign will change, positive to negative. But look at this. This time round for cos, it's cos A cos B, followed by sine A sine B. Right? But there's not only the sum of the two angles, there's also the difference between two angles. Okay, and that is cos A cos B. Remember, minus, then we'll change to plus, and then sine A sine B. Okay. So if we look at some examples very quickly where we can apply this, let's look at this one. So cos of alpha plus 60 degrees. Alpha is a Greek alphabet, guys. Alpha plus 60 degrees. Okay. That will be equal to, remember, there's our template. Okay, cos A plus B is cos A cos B minus sin A sin B. So that means it will be cos of alpha cos 60 degrees minus sine alpha sine 60 degrees. Okay, that is the template. And then because we know that 60 degrees is a special angle, we are then going to substitute. We know that is a special angle, so we say cos of 60 degrees, that's a half minus sine alpha sine 60 degrees sine of 60 degrees, that is equal to root 3 over 2. Root 3 over 2. Okay. Yeah. Okay. Okay, just one more example. Cos of x minus 20 degrees, that will be equal to cos x cos 20, and since it's minus, minus changes to plus, sine x sine of 20 degrees. Okay, and that's simply that. We've expanded, so that's how we expand the compound angle. Whilst we are still on that same note, guys, there are questions sometimes that require us to write the following. Since we are still on compound angle, write the following as a single trigonometric ratio. What do we do when we are asked to write the following as a single trigonometric ratio? Write the following as a single trigonometric ratio. So in as much as we know how to write the expansion of a certain compound angle, we need to be able to take the expanded form and write it back as a reduced form. Okay, I hope that makes sense. So we need to be able to, for instance, if we are given sine A cos B plus cos A sine B, we need to know that this is equal to sine A plus B. Okay, that's writing an expanded form into a single trigonometric ratio. Okay, so in as much as we need to know the expression of sine A plus B, we need to be able to reduce it back to its compound. Okay, that's very important. So that's where writing the following as a single trigonometric ratio comes into play. So I'm going to look at a few examples under this thing of writing something as a single trigonometric ratio. So let us look at some examples. So let's look at a general example to begin with. Sine x cos y minus cos x sine of y. So if you look at this, guys, okay, this will be equal to what when it's reduced? So sine x cos y minus cos x sine y. Remember, we have sine and cos. The minute we have sine and cos, cos and sine, that tells us that we have the sine compound angle. So we know for a fact, because there's different sine, cos, cos, sine. So that means this is the sine compound angle. Now, what do we know about the sine compound angle? Inside the bracket, if this is negative, this will also be negative because the sign does not change. This is xy, xy. So that means x comes first, y follows. So therefore the reduced or the single trigonometric ratio of the expanded form is sine x minus y. Okay, let's look at another one, number 2. Cos alpha cos 12 plus sine alpha sine 12. So here's another one. This is the expanded form, and we are supposed to write it as a single trigonometric ratio. So let's go. This is cos cos sine sine. Now the minute we say cos cos sine sine, that speaks of which trigonometric ratio? That simply means we have this is the cos, okay, single trigonometric ratio, the compound. And then basically inside the bracket, we open two brackets. We know that if it's cos, then obviously there's a change in sign. So there's a negative sign inside. Then alpha 12. So that means alpha followed by 12, because in say alpha 12, alpha 12. So alpha followed by 12. So this is basically us reducing using that template of the compound angle of cos. Okay, that's one single trigonometric ratio. So we are doing the reverse now. Okay, and that's very key. Let's look at maybe a little bit more complex. Sine x minus 20 degrees cos 20 plus cos x minus 20 degrees sine 20 degrees. So once again, we need to write the following as a single trigonometric ratio. So if we look at this, guys, look at it very closely. Sine of x minus 20 degrees times cos of 20 degrees plus cos minus 20 degrees, x minus 20 degrees times sine of 20 degrees. So if you look at the template, guys, that we have here, we have sine cos, cos sine. So the sine cos, cos sine obviously speaks of which trig ratio? Sine. Okay, then we have sine cos, cos sine, and here the sign is positive. So obviously for cos, we know that sine means the same sign. So we know plus is in the middle. But then what do we start with? We first start with the x minus 20 degrees. Okay, plus what? Plus the 20 degrees. Okay. Okay. And obviously we could put this in smaller nyana brackets, plus the 20 degrees. We put that in smaller nyana brackets. But then obviously we are going to look at the inside and look, are there like terms? So we remove this bracket, which becomes x minus 20, and then we take the plus 20, we multiply with the positive 20, it becomes positive 20. So the like terms we have here are x minus 20 plus 20. And of course, minus 20 plus 20 gives us 0, so our final answer is sine of x. Now this has just been what? Reduced. This we have written sine x minus 20 into cos 20 times cos 20 plus cos x minus 20 times sine 20. We wrote it using the compound angle as sine of x minus 20 plus 20 degrees, because that is the reduced form of the expanded compound. Then we added the like terms, as you can see. Minus 20 plus 20 gives us 0, so we are left with a single trigonometric ratio, which is sine of x. Okay, guys, I hope you guys can see this, that we need to know how to expand, but at the same time we need to know how to write down the compound expression, expanded form, as a single reduced trigonometric ratio. Okay, so hopefully you guys are seeing like how fluent this all can be. Let's look at one more example of reducing, so that we can comfortably say that all is well in Zion. So cos cos of x plus 30 degrees into cos 45 minus cos of x plus 30 degrees into cos 45. So let's look at this example, guys. So SS, please. What's SS? I don't know what SS means. Okay. cos of x plus 30 degrees into cos 45 degrees minus cos x plus 30 degrees into cos 45. Remember the question was saying, right, this is a single trigonometric ratio. So, sorry, not cos. This is supposed to be sine. Sine, look, I even wrote down the question incorrectly because I'm seeing SS on the screen. Why? I don't know. So cos x plus 30 degrees times cos 45 minus sine x plus 30 degrees sine 45. Okay. So here we go, guys. Remember, this is cos, sine, sine. So that means this is the cos compound. Okay. Yeah. And then we open that bracket. What do we have? This would be our A, this would our B. So our A is x plus 30 degrees. Okay. And remember, the negative sign changes to positive. Okay. So this is like x plus 30 degrees, that's our A, plus, not 30 degrees, sorry, that's 45. So that is 45 degrees. Guys, I'm really distracted right now. I think, I don't know, x plus 30 degrees plus 45 degrees. Let's see. Now we can go inside and add the like terms. So x plus 30, we remove the bracket for x plus 30 plus 45 degrees. Now we can add. So that means cos of x plus 75 degrees. Okay, so this is the reduced to a single trigonometric ratio, as we had been asked in the question. Okay, so basically, guys, your formula sheet here is very important. Okay, and what's beautiful is that you guys are given the formula sheet, so your compound angles are always available for you to be able to use whenever you need them. Okay, so there is no difficulty in that because your formula sheet is always there. It's always there to be used. You can use it whenever you want. And basically, all of these compound expressions, they are there so that you can be able to look at them and use them. So I just want to say, it's important to know, like I said, how to expand the formula sheet. You always utilize it whenever you are faced with a particular problem, where you can easily see that you are supposed to use the expression of the compound angle. Just pull out your formula sheet and look at the expression so that you can be able to write out the expanded form as you would, of course. All right. So please, formula sheet, and I cannot overemphasize the formula sheet. Okay. So use it, don't abuse it, but use the formula sheet as much as possible. Okay. Yeah, I'm still kind of getting some of the basics out so that people can see, these basics. It's very important. All right. I just let's check this one out. Sine 6x sine 5x plus cos 6x cos 5x. So if you look at this one, guys, sine 6x sine 5x plus cos 6x cos 5x. We need to write this as a single trigonometric ratio. So if you look at this is sine, cos. But usually, guys, the cos usually starts, So I'm going to rewrite this, okay? And there's a reason why I'm going to rewrite this so that it actually mimics the same expansion of the compound, for cos. So this is cos 6s cos 5x. Cos usually starts, and since there's an addition sign, I know in maths from grade 8 and 9 that addition is commutative. So that means, in other words, I could write cos 6x times sine 5x, okay? And then say plus sine 6x followed by sine 5x. This here is no different from that, all right? Because it's like saying a plus b is the same thing as b plus a. Or in other words, 1 plus 2 is the same thing as 2 plus 1, all right? So basically, I am just writing this out, rewriting it. Why? Because I want to see my expanded form in the way that the template of cos for the compound angle usually is, because it usually says cos cos. So sorry, I changed the sign into cos. Why? I don't know why. So forgive me there. This is cos 6x, cos 5x. So there is it. It is cos 6x, cos 5x, followed by sine 6x times sine 5x. Now I can write the reduced form. So this is cos cos, sine sine. And remember, if it's cos cos, it means that is cos, the cos compound angle. Okay. Then inside the bracket, what do I have? 6x. And remember, if there's a plus here, C stands for change in the sign. So that means 6x minus 5x. Obviously, you can look at the template of the expanded form of the compound angle, and obviously you're going to see that if there's a plus, then obviously inside the bracket there's a minus. What's cos 6x? What's 6x minus 5x? The like terms give us cos x. And there it is, guys. That's a single trigonometric ratio. And I can't leave it in this form. I need to leave it as a single trigonometric ratio. If there are like terms inside the bracket, then I have to actually take care of those like terms. Okay? Yeah. So hopefully those who are seeing this are seeing it for what it is. And it's making a lot of beautiful sense. Okay? Okay, let's look at another one. Cos 14 times sine 6 plus cos 6 times sine 14. Right, this is a single trigonometric ratio. So once again, look at this. Cos 14 sine 6, cos 6 sine 14. All right. So once again, when you look at this, I'm looking at it and I'm like, Haibo, it does not mimic the template of the expansion of either the sine or the cos. But I can see there's cos sine, cos sine. So that means there's different trig ratios on either side, which means that this kind of mirrors the sine, reduction, the sine reduced compound. So, but I need to rewrite it so that it actually is what I know. So what I'm going to do is I'm going to swap around the cos 14 and the sine 6. And the reason why I do that is because with multiplication, once again, multiplication is also commutative. In other words, A times B is the same thing as B times A. You can say, in other words, 1 times 2 is the same thing as 2 times 1. What you get is the same. So what I do here is I'm going to rewrite this so that it is basically mirroring the template of the sine. So I know sine 6 would start followed by cos 14. Okay, and then plus. This obviously is fine. This is cos 6 followed by sine 14. So this fine, it mirrors that template that I told you about. Now I'm going to, because it's sine cos, cos sine, I obviously know that is sine. Okay, why do I know it's sine? It's because it's sine cos, cos sine. This is like the A, this is the B, this is the A, this is the B. So it makes perfect sense. So in brackets, I'm going to write 6. But then there's a plus sign, which means for sine, I know that it is the same sign. So it's 6 plus 14 degrees. Then I'm going to write sine. What's 6 plus 14? It's 20 degrees. That is the single trigonometric ratio, as simply as you can get it and as nicely as you can expect it. Okay. Yeah. Okay. So yeah, guys, I hope you guys are kind of like seeing this writing as a single trigonometric ratio. Okay, let's move on and look at another type of question, sort of like in the same vein. We are asked to simplify the following. All right, so yes, I'm getting the basics in, and I know for some of you, you might be like, but come on, can't we just move on to the more complex stuff? Guys, remember, complex problems are simply the result of being able to do the basic problems. So it's very important to know how to do the basics. Basics, if you know how to do the basics, the complex problems cease to become complex. They become routine problems. Okay. So let's say, for instance, we are given sine of theta minus 45 degrees plus sine of theta plus 45 degrees. So when we look at this, we need to look at it and be like, how many terms do we have in the trigonometric expression? There are one, that's one term. The plus sign separates the terms, that is 2. Okay, so this is a particular compound. Okay, and this is also a particular compound. So if I'm going to simplify this, then it simply means I need to first expand this compound. So I need to expand this compound, and then I need to expand that compound. So let's go ahead and do it. So we are using sine. So let's go. So that means sine theta cos 45. Remember, S means same sign, so that means minus cos of theta sine of 45. So I'm done expanding the first one. Then I need to say plus. Remember, this plus sign is this one. Then I'm going to expand this one. So that means I have, just going to use a different color, sine theta. Okay, I'm going to put brackets around that, because in the event that that was a minus sign, obviously that would affect the expansion, because the plus sign is preceding this particular compound. So that's why I'm putting brackets for everything that's inside. Sine theta cos 45 plus cos theta sine 45. Okay, so there it is. So now it's like we are back to grade 10, where we are dealing with terms, and then after we after we actually write down the expression of the compound, now we have to actually take the plus sign and distribute it. If we distribute the plus sign to this first term, this remains positive. If we take the plus sign, we distribute to that positive sign, that also remains positive, so it doesn't change anything. Okay, so let's just write all of this. Sine theta cos 45 minus cos theta sine 45 plus, when you distribute the positive sign, nothing changes in the brackets, because plus sign doesn't change nothing inside the bracket. Then what do? We are going to look for like terms. Okay, this is like xy minus xy, it's like xy minus something else, you see. So these are like terms. Sine theta cos 45 is a like term with plus sine theta cos 45. So how many sine theta 45s do we have? We have 1, 2. So that means we add these two together. That means our answer will be 2. Okay, please guys, sine theta cos 45 plus another sine theta cos 45 means 2 sine theta cos 45. I hope you guys understand that. Then this is a like term with that. Okay, so this is a like term with that. That's negative cos theta sine 45, and that's positive cos theta sine 45. So this minus that is 0. So that means I'm left with the answer of 2 sine theta cos 45. But then remember this here, what is this? This is a special angle. So since that is a special angle from my previous grades, I know cos 45. What is cos 45? So you go to your beautiful calculator, you type it in, because you've forgotten, you don't even know the triangles anymore. But in grade 12, you know very well you can use the calculator so confidently. So you have root 2 over 2. okay? But then this 2 times this, so basically 2, which is in the numerator, and this 2 is in the denominator. This is multiplication relationship, so this 2 and this 2 will cancel, and you are left with the answer of root 2 sine theta. Do you see, guys, how beautifully we moved through this problem? Okay, so like I said, we are asked to simplify the following. We look at the problem, we see that there is the plus sign, there's a second term. So there are 2 terms of compound angles, okay, both sine. So we must expand this first term. That's what we get. Plus, then we make sure we put a bracket around this entire expansion of the second term. All right. Then what do we do after that? We distribute the plus sign inside this bracket so that it removes the bracket. Please make sure to always put brackets, guys, if there's a sign that is preceding an expansion that you've just done, because this plus sign will go into the bracket distributed to the 2 terms. This term remains positive, that term, a positive times a positive, it remains positive. Then what you do then is you add like terms, and you're going to be asking like the question, how do you know that these are like terms? Guys, look at this. This is sine theta cos 45. This is also sine theta cos 45. Okay, yeah, so this is no different from saying xy, and this is another xy. Xy plus xy gives you 2xy, but instead of x and y, we have sine theta and cos 45. So that's why we say 2 sine theta cos 45. Then we have these like terms, minus cos theta sine 45 and plus cos theta sine 45. These 2 obviously will give you 0. So that's why your final answer, you have 2 sine theta cos 45. Then the cos 45 you convert to a special angle using your calculator. Guys, we use our calculator in grade 12. We don't mess around with special angles, okay? And try and use the triangle and stuff. That gives us root 2 over 2. We show that appearance of root 2 over 2, then obviously we multiply. This is algebra, guys, simplification of algebra. 2 times the root 2 over 2, obviously the 2 and the 2 will cancel, you'll be left with 2. Remember, when the 2 cancel, this is like saying 2 divided by 2, which leaves you with 1. Okay, then the 1 times the root 2 gives you root 2 sine theta, and that's our final answer. Okay. Nice, straightforward and simple, no problems, no cry at all. Okay, let's do some others so that you can kind of become a bit more familiar. Okay, let's look at this one. We also need to simplify cos of x plus 60 degrees cos of x plus sine of x plus 60 degrees sine of x. We are told to simplify. No, omolimo. No, you can't say that. No, that's very dangerous. Thank you for saying that. No, we can't say that at all. No. Omolimo. Look at this. Omolim, if you have 2 outside the bracket and you have a times b, okay, remember a times b is ab. When you take the 2 and distribute inside the bracket, do you say the answer is 2a 2b? Do you say that? Like, were you doing that in grade 8 and grade 9 and grade 10? It will end at 6:30 and as a pora. Okay, but if you need to leave before then, that's fine. I will be uploading this onto the YouTube channel. Okay, so omolimo, you can't say that. Okay, I'm glad you asked the question. 2 into a times b is actually equal to, what's 2 times ab? It's 2. It's not 2a 2b. This is equal to 2ab. Okay, so you can't say 2a 2b. No. Okay, the relationship between a and b is multiply. So all you do is you take the 2, you multiply with ab. 2 simply becomes the coefficient of the 2 variables a and b, and that's it. Okay, the only time you distribute something, if there's something outside, is if there's a plus or a minus sign. Okay, then you would say 2 times A, 2 times B. So that's 2A plus 2B. 2 times A, 2 times B, that would be 2A minus 2B. Okay, I hope that makes sense. Hence I was saying, for instance, after this expansion of sine theta plus 45 degrees, there's a plus sign that is waiting on the outside. So we put brackets, right? Then we expand sine theta plus 45. This is sine theta cos 45 plus cos theta sine 45. This plus sign needs to be distributed for this single term, and then this plus sign needs to be distributed for this single term. Because remember, multiply combines things. Addition and subtraction separates. That's why this plus sign can be distributed for this one term. This whole entire term is positive. Okay, and then this plus sign gets distributed for this one term. This whole entire term is also still positive, because a positive times a positive is positive. So please, guys, these are basic algebra manipulations from grade 8, in fact from grade 8, 9 and 10. Okay, and what you understand from those simple basic manipulation should then apply, because here we dare not say 2 sine theta 2 cos 45. It completely changes the entire answer and it makes it something else that is incorrect. So thank you for asking that question, Omolim. Okay, I'm very glad. Now this is the kind of interaction I like having, so that we can have clarity. Please, guys, when there's something that I say or do and maybe in your head you find that you think of it a bit differently, please don't be scared to use the comment section and ask whatever question you need or to seek clarification. It's very important. Now let's look at this one. Cos x plus 60 times cos x plus sine x plus 60 times sine x. So here we need to simplify. So we can clearly see this is cos cos, this is sine sine. This is like the A, this is the B, the same A and the B. So this is the cos compound. So we are going to write cos, and then of course in brackets we would write the x plus 60 degrees, which would be like our A value, followed by what? Remember, for cos the sign changes, followed by x, negative x, and that's that. Do you see that, guys? I hope you understand this. Okay, because this is like AB, AB, cos cos, sine sine. So we know this is the cos compound. So x plus 60 followed by negative x. So then inside the bracket we can remove the small bracket here, x plus 60, okay, and then minus the x. So we have like terms there. What's x minus x? That gives you 0. So we have cos of 60 alone, and then of course, what is this? This is a special angle. So since it's a special angle, what do? We take our trusted calculator, we just type in cos of 60 equal, it's a half. It's a half. And there it is, a half. And that's done. Okay, that is done. Yeah. Right. Let's look at another one. We are asked as well to simplify here. There it is, cos of A plus 60 degrees in brackets minus sine of A minus 30 degrees. So we are asked to do what here? To simplify. Simplify, simplify, simplify. So let's go. Cos of A plus 60 degrees. This is the compound angle for cos. Okay, very important. This is the compound angle for cos. This here, compound angle for sine. So we can expand this and expand that. Take note of the negative sign. It separates these two terms. So let's expand the first one. This is cos A cos 60, change of sign, minus sine A sine of 60. Remember guys that the minute you forget, use your formula sheet. Please guys, I would suggest you make sure, if you don't have a formula sheet printed out, print it out and have a formula sheet handy, because when you do these, you need to be constantly referring to the formula sheet as someone who is beginning doing something like this, a section of this nature. So this is finished, expanded. Then there's a minus sign. Let's take note of that minus sign. Then we write brackets so that we can expand this one. The minus sign waiting patiently to be distributed after we expand. Sine A minus 30 degrees. This is sine A cos 30. Same sign, remember, for the negative, so that's still minus cos A sine 30 degrees. Okay, do you see that? The bracket, guys, the negative sign outside. Then let us continue. Cos A cos 60 degrees minus sine A sine 60 degrees. We take the negative sign, we distribute it. This is one term, guys, one. So that means the negative sign gets distributed. Here we get negative sine A cos of 30. Negative distributed first here, then the negative distributed to the middle. Negative times a negative gives you a positive cos A sine of 30. Do you see this, guys? Now that we have this, there's no like terms that we can add and subtract. But what's beautiful here is that cos A and cos 60. Cos 60 is a special angle. Since we have no like terms, all right, then we can go on and we can check what specifically converting our special angles. So cos A will be followed by cos of 60. Cos of 60 is a half minus sine A. Then we check sine of 60 in the calculator. Sine of 60 degrees, no problemo. We get root 3 over 2. Followed by sine A, we write cos of 30 degrees. We just grab our calculator. It helps us out. We get root 3 over 2 again. Plus cos A, sine of 30 degrees. We just grab that again. Sine of 30, that gives us a beautiful sweet answer of half. Then I'm sure you can see, now you can see evident like terms. Okay, the evident like terms that you see here, cos A half. In other words, half cos A, because multiplication is commutative, minus root 3 over 2 sine A, thank you Kenzo, minus root 3 over 2 sine A, that's another one, plus half cos of A. Okay, obviously these become the coefficient of each trig ratio. So now I'm sure you guys can see that there's an addition of like terms. Cos A is the same as half cos A. When the denominators are the same, what do? When the denominators are the same, guys, we simply add the coefficients for the add the numerator, sorry, when the denominators are the same. So what we have here is 2 over 2, the trig ratio stays the same, so this plus that gives you 2 over 2 cos A, and then here these are also like terms, minus root 3 over 2 sine A minus root 3 over 2 sine A, that gives you a negative 2 root 3 over 2 sine A. And then this can be simplified. 2 over 2 simply gives you 1. So we have cos A, and then 2 over 2. This 2 and this 2 cancel out because we can cancel. The relationship between the 2 and the root 3 is multiply over divide. So this 2 and the 2 definitely can be cancelled. That happens when there's a relationship of multiplication in your numerator or your denominator, and there's division alone. With multiplication and division alone, you can simply 2 divided by 2 is 1, so we're left with negative root 3 sine A. Guys, there's nothing more we can do to simplify this problem. It simply ends there. Cos A minus root 3 sine A. Okay? Guys, I don't know if this needs any other form of explanation, but this is how we simplify a problem of this nature. If you guys have any questions in the comment section, I'd hope those would come. Thank you so much, Anati. You're very kind and generous. Appreciate it. If there's any questions or any comments that one wants to make, I just want to review this. Like I said, all I did is I looked at this. This is one term minus, this is a second term. Remember, plus and minus separates terms. I learned this in grade 8 and 9. Then what do we do here? We expand using our compound angle. Okay, formula sheet would help us out. Then also look at the minus sign. Be very careful. The minus sign needs to stay. We need to write brackets. Why? Because this minus sign, after expanding, needs to be distributed to the inside. So we expand that. Okay, sine A cos 30 minus cos A sine 30. We expand the negative inside the bracket. We get negative sine A cos 30. Then the negative times this negative gives us positive cos A sine 30. Then we can see that there are no evident like terms. So what we do is we take the special angles, we write them in our special angle ratios. So we use our calculator for that. Cos 60 was half, sine 60 is root 3 over 2, cos 30 is root 3 over 2, and then sine 30 is a half. Okay, and all we do is we simply, since multiplication is commutative, half, we just write that as a coefficient, followed by cos A, root 3 over 2, coefficient, followed by the trig ratio, root 3 over 2, coefficient, which is negative root 3 over 2, followed by the ratio. Okay, and then again here, coefficient of half, followed by the trig ratio. Okay, and just again for tohu here, or toru, the negative, when you distribute a negative sign to this becomes negative. Obviously, all of it. This is a multiplication of two things, so this is negative sine A cos 30. But in algebra, we know a negative times a negative gives you a positive. Okay, so that's why this is positive. It's no longer negative. And that's why I'm saying to you guys that you must recognize that after the expansion, this negative sign ought to be distributed inside this bracket. So that's why you ensure you put a bracket. Okay, yeah, and I hope you understand. Then we add and subtract the like terms. Half cos A plus half cos A. That obviously you can add the coefficients. This is the same thing as saying half x plus half x. Obviously, half x plus half x, you keep the variable, which in this case is cos A, and then you add and subtract the coefficients. So half plus half gives you 2 over 2, which is 1. And then here, these are also like terms. Okay, negative root 3 over 2 minus negative root 3 over 2 gives you 2 root 3 over 2. And that's why this 2 and this 2 cancel. You're left with negative root 3 sine A. Okay, bongs, then you are boss, my leader. If you come onto the live, you've been here for 5 minutes and you understood me, then that means you are phenomenal at understanding someone. You catch on very well, very well. Okay, let's do one more that's like this. Okay, hopefully I've driven in the concept here, but let's do one more. And yeah, simplification is very important. Root 3 cos x minus 30 degrees. Okay, Liabona, that's fine. Root 3 minus cos of x minus 60 degrees. Okay. Puka blinds. I don't know what you mean by 0 out of 0, but I hope it's not a negative comment or else. Okay, root 3 cos x minus 30 degrees minus cos into x minus 60 degrees. So once again, what you can see here is we have a root 3, okay, and this root 3 is external, okay. So this time around, what we are going to do is we are going to expand this. The root 3 needs to wait outside. So now we are going to have a bracket here, expand cos x minus 30 degrees, and the root 3 will come in later. So let's expand cos x minus 30, because how many terms do we have? We have one term followed by a minus sign. This is a second term. So there are two terms in our expression. So we compound expand this one. So basically we are going to get cos x cos 30, but then remember the sign changes to plus, okay, sine x sine 30 degrees. Please use your formula sheet, guys, for expansion, so that if you've forgotten, you can expand correctly. Then remember, this is followed by a minus sign. So we put the minus here, then we expand this one. But since the minus sign is there, we put it in brackets. Please, guys, we put brackets there because this root 3 needs to come in and be distributed because it's there. So whatever, guys, is preceding our compound, we need to make sure we put brackets, because this will be expanded, will be distributed inside after we are done. It's like if there was a negative here, we would open the brackets and we distribute the what? The negative afterwards. This is very important. Okay, it's grade 12, man. Then here we have the negative sign. We're going to compound angle. We're going to actually now write the compound angle for this. Okay, so let's go. This is what? Cos x cos 60 followed by the minus changes to plus sine x sine 60. Okay, so hopefully you guys can see this. Look, you see, beautiful, ne? Beautiful, beautiful, beautiful. Now it's time to, before we distribute the root 3, let us do anything else. Let's first make sure that we write these special angles. But before we even do that, let's not be in a hurry. Let's take this negative sign and distribute it. This then becomes what? Negative cos x cos 60. And this negative times a positive gives us a negative sine x sine 60 degrees. Because a negative times a positive is a negative. Now, let us rock on. Okay, let's just finish all of this. Okay, we are distributing the root 3 for this bracket. We distributed the minus sign for the other bracket. Okay, I should have done that even initially, okay, because I'm just dragging it out unnecessarily. So when I do the distribution, I should have just done the distribution for this as well. So basically this step, okay, this step would have been followed by this one. The root 3 I distribute for this term, it becomes root 3 cos x times cos 30. Then I distribute the root 3 for this term. This becomes positive root 3 sine x sine 30. The minus I've already distributed for this bracket. There's the negative. This positive changes to negative, so you can see that. Now, there are special angles that need to be attended to. So I'm going to attend to those special angles. Cos 30. Remember, cos 30, even in the previous problem, cos 30 we had find is root 3 over 2. But we typically use our calculator. Okay. And then plus root 3 sine x sine 30 is actually equal to a half. Okay. Minus cos x cos 60. Remember, cos 60 is also equal to a half. If you use your calculator, you'll be able to find it. Minus sine x, and then sine 60 is actually equal to root 3 over 2. Okay. Now with that said, we can multiply this. Okay. Root 3 times root 3. This root 3 and this root 3 are both in the numerator. That will give me 3 over 2 cos x when I multiply root 3 times root 3 over 2, okay, you can even use your calculator if you really sort of like you're not confident about getting the answer. Root 3 times root 3 over 2, you will get 3 over 2 as your answer, plus root 3 times a half will give you root 3 over 2 sine x, minus half times cos x, a negative times half cos x is going to be a negative half cos x, and then last but not least, root 3 over 2 times the negative sine x gives you minus root 3 over 2 sine x. Now that I'm here, what do you notice? This is like term with who? With this guy. This one is like term with this one. So root 3 over 2 cos x minus half cos x. 3 minus 1, because the denominators are the same, I just simply say 3 minus 1, which gives me 2 over 2 cos what? Cos x. Okay? And then look at this one. Root 3 over 2 sine x minus root 3 over 2 sine x. These two guys will give you 0. This minus that gives you 0. So therefore, I get 0. That means my answer is, obviously, 2 over 2 gives you 1. And that's 1 cos x, which is actually equal to what? Cos of x. Okay. Guys, I hope you, I don't know, I hope this was a nice meal, and it kind of really helps you to see compound angles in a different light. Okay, I'm doing compound angles alone right now, and I'm obsessively focusing on them so that you can see how these compound angles can actually now be applied practically in some examples. All right, that's why I'm actually doing them exclusively alone. All right, so I hope you guys can appreciate what it is I'm doing. All right, I'm gonna do just two last problems, okay, that basically say the following. Calculate. Thank you, Mars. Thank you, Mars. Thank you so much. Really appreciate that. Calculate the following. You are very generous. Thank you. Thank you so much. Calculate the following without the use of a calculator. So just understand, when I say WUC, I'm going to be using this quite a bit in my live sessions. When I say WUC, I mean without the use of calculator. Thank you, Ashley. Calculate the following without the use of the calculator. So very quickly, or very nicely, I just want to look at a few of these problems. We have sine of 75 degrees. What? Sine 75 degrees? How in the world do I calculate this without using the calculator? So in other words, what they are saying, when they are saying without using a calculator, they are saying, do not just take your calculator and say sine 75, and then basically you get the answer. The point is you need to show steps. Okay? So what we do, guys, is we look at this 75 degrees and we look at it in light of some of these beautiful special angles we learned. There's 30 degrees, there's 60, there's 45 degrees. I want you guys to play around with these, 30, 45, 30, 60, 45. You can play around with them. For instance, you can add 60 and 45, you get 105. You can subtract 60 minus 45, you get 15, all right, and so forth. So what you have here is 75 degrees, and what you want to do is you want to use your special angles to basically formulate a compound angle, all right, an addition or a subtraction of two angles that will give you 75 degrees using your special angles. So Anati Tafeni, you are very much spot on. So what we do is we are going to write 75 degrees as 40 plus 35. Now I just wanted to do that on purpose. Now can you see, if we said 40 plus 35, what would we be saying? Yes, 40 plus 35 is definitely 75, but are these special angles? No. So this is not going to help us or assist us at all. So yes, like Anati Tafeni said in the comment section, we can write sine of what? of 45 degrees plus 30. Okay, and that's 100% spot on. So Anati Taveni, you are the main girl currently. You are the main girl. So this would be incorrect, but we would embrace this wholeheartedly because we have utilized the special angles that we have. Now we must expand this. Okay, so this means special angles and then expansion after we have special angles. So now we can expand this. This is sine 45 cos 30 sine cos 45 sine of 30. Then of course, guys, we have special angles. So this is very nice and sweet. All we need to do is just utilize our special angles. So this is root 2 over 2. Okay, I don't know about you, but I tend to forget these special angles very quickly. So that's nice that I have my trusted calculator. But people are like, Aibo, but sir, why are you using a calculator? Because, guys, all right, I am showing the steps, and in grade 11 and 12, okay, we can now use the calculator to actually get the special angles. Okay, sine of 30. Yeah, so that thing of without using a calculator simply means you need to show steps. Okay, you need to show your steps. That's what they are basically, in essence, trying to help cultivate in the students. Then all you do now, board mass will apply because you have different operations. So obviously multiplication gets priority over addition. So we are going to multiply these two. Please, guys, whenever you have different operations, board mass takes priority, right? So root 2 over 2 times root 3 over 2. That's 2 times root 3, which is root 3 root 2 over 4. Okay, plus. Okay, then here we have root 2 times 1, root 2 over 4. Then these are like terms. And the denominators are already what? The same. So what we do is we keep the denominator, we add the numerator. So we have root 3 root 2 plus root 2. Okay, and I know, I guess for the purpose of those who may be simplifying, obviously that means 3 times 2 plus root 2 over 4. So that would basically give us root 6 plus what? Root 6 plus root 2 over 4. And we leave that answer in that form. That's it. Remember, no need to rationalize the denominator in this case. We can actually leave it in this form. We do not put this in the calculator and get the decimal number. Why? Because we are told without using the calculator. That would be evidence, guys, that these people, so we leave this in this form. We cannot do otherwise. Okay, yeah, I'm gonna do one last one before I love and beautifully leave you. Let's do this one last one. Okay, I just want to look at this problem quickly, guys, before I leave, because this is kind of like round about the time where I'm like, it's hot that I leave. If I don't, then I might find myself being late for work. So negative sine 40 times cos 10 plus cos 40 times sine 10. Okay, and remember, guys, I'll be coming back live again tomorrow at 5 o'clock. I wake up, so 5:15 roughly. I'm done, ready to go. Okay, so 5:15 tomorrow morning, grade 12s. I'll continue from where I left off. We'll continue with double angles, and then we'll just take it one step at a time moving forward. So negative sine 40 times cos 10 plus cos 40 times sine 10. Okay, so what you're seeing here is sine cos, cos sine. Okay, but then the thing is, there's a negative here. So this negative would suggest that this is basically our first term and it's negative. All right, so what you would do is you would take out a highest common factor. Okay, and this is very important. You take out the negative. What are you left with? Sine of 40, cos of 10. This plus changes to minus cos of 40, sine of 10. You think that you've left factorization and all of those things behind, but you haven't. In trig in grade 12, you find that most of these problems, the only reason why for some people trigonometry is difficult is because their algebra, simplification and factorization is not on point. So you need to then cultivate that skill of being fluent in your factorization and your simplification. So what we've just done here, we've realized that this is sine 40 cos 10 plus cos 40 sine 10, but the first term is negative. And there's a rule in factorization that when the first term is negative, you must take out the negative sign as a highest common factor. And this is the thing, guys, SFI. Whenever you are dealing with simplification of something, you need to first check, is simplification possible? If not, you check, is factorization possible? That's what the F stands for. And if not, the use of your identities. Okay, so you cannot use the compound angle identity until such time that the simplification has been done. So simplification not, but factorization definitely, because even though we can see this is a compound and it is a compound for sine, the only problem is that we have a negative sign as our first term. So therefore we need to apply factorization, take out the negative so that we can see what the expression actually is authentically. All right, so that we can see, oh, this is the compound angle. Compound angle for what? For sine. And this is 40. Obviously the same sign remains, it's sine 40 minus 10. Remember, there was a negative sign outside the bracket, and that is still there. Then we deal with what's inside. 40 minus 10 gives us 30 degrees. Do you see that, guys? So now we have sine of 30 degrees, but it's negative, okay? Then sine of 30. What is sine of 30 as per our calculator? It is a half. And the negative sign is still there outside waiting. Now the negative sign can penetrate and then basically we can have a negative half. So the negative sign now can basically be distributed, and the answer is a negative half. I hope you guys can appreciate this mindset of whenever you have a compound expression, you know fully well how to deal with that particular compound expression. If it is that, let's say, for instance, this was not negative. But the minute you have a first term that's negative, then you need to somehow do what? There's a rearrangement that has to happen, or there is some sort of factorization that has to happen. So here, definitely we're taking out the negative. We have sine 40 cos 10, and this basically, that expression leads us to our compound reduction. We then obviously have a special angle. We write it down. The negative sign can be applied. The answer is a negative half. Okay, guys, let me love and leave you. Thank you so much for joining in. So this was compound 101, like literally the basics. Okay, very, very crucial and critical, guys. I am very grateful. Thank you so much, Mars. Like, oh my goodness, you're so generous. Thank you so much. Really appreciate the roses. And thank you, guys. I hope you guys have a beautiful day, amazing Monday. I hope your Monday starts off on a pretty sweet, amazing note. I will definitely be, obviously, downloading this and uploading it on the YouTube channel, as I've done with the sessions we did yesterday, and as moving forward and continuing. Unfortunately, this guy does not have any sort of etiquette when it comes to neatness and all of that. So I just upload those live sessions as raw as you would see them, and as you find them here. There's no editing of any sort, but hopefully the maths is still sort of assisting and helping us very much. So have a good one, and thank you so much again. Thank you, Anati, thank you, Tia, and thank you to everybody else that joined in, those who commented, those who were asking questions, those who joined in midway, who were able to pick up what was happening. That speaks to your guys' intelligence and genius. It's amazing. Maths is easy. Maths is the game. We definitely can play it. We can all play it. So cheers. Let me see you guys. See you tomorrow, same time, 5 a.m. guys. I'm shooting for 5 a.m. but most likely probably get started at 5:15 officially. But yeah, have a good day guys, and thank you again.